Testing. Test. Alrighty. Good morning. So, a very good morning to all. Welcome to this first ISTEC Distinguished Lecture for this semester in 2018. Before we introduce the speaker, I just wanted to say a couple words about ISTEC. For those of you who are not familiar with ISTEC is the Information Science and Technology Center here at CSU, where we deal with all things related to information sciences and technologies, encompassing research, education, and outreach. One of the activities we have every semester is our Distinguished Lecture Series program, and we're starting that off today. There is food at the back and coffee as well for those of you who are interested. Let me get to the front here, the host of our distinguished lecture for today, Sanjay Rajopadia from Computer Science.
Welcome everybody. It's really a great pleasure for me to introduce Monica Lam. Anyone who's taken a class in compilers knows about the Dragon book, and Monica is one of the four authors on that book. And the earlier editions of that book had very little about automatic parallelization and parallelizing compilers, and I got to know her when she was getting into this field. I remember inviting her to University of Oregon in '88, just after she had started her faculty position at Stanford, and she has made pioneering contributions, not only to parallelizing compilers but systems in general. Many of her students are leaders in the field today, so without further ado,
well, thank you, Sanjay. Well, thank you for inviting me. I'm glad to be here. You can hear me okay? All right. So, how many people know what virtual assistants are? Alexa, Siri, Google Assistant. As a matter of fact, everybody who watched the Super Bowl would know what a virtual assistant is. You know, Amazon put out this big ad about virtual assistants, and it is really fast becoming something that consumers know. I mean, it's not just a computer science thing, but it is everybody is knows about it, and a lot of people are using it. And what I want to say today is that when these virtual assistants grow up, you know, Siri and Alexa, they can be a potential threat to the open internet. And I want to tell you why I think so. And the question is, can we change that? Can the computer science people do something about it early? Okay, it is still kind of at the early stage. And my message here is that the world really needs an open source virtual assistant, and I'm going to talk about how we are building one. Let's take a look at what happened in the last 20 years. You guys know Marc Andreessen? He's a very famous VC, but he's also the author of the first most popular browser, the Mosaic browser. And he coined this phrase. It's 4 little words. It says, software eats the world. And boy, did software eat the world in the last 20 years. And today, I think that there are 5 kingdoms. Okay, you know, there are kingdoms in the old days. They're coming back in this digital form. Okay, they kind of run the world in their ways. And there are 5 such software kingdoms. And if you think for a minute what these 5 kingdoms are, they're probably the same as my 5 kingdoms. All right. But what is interesting about them is to look at their business models. And I'm going to rank them from the most conventional to the most innovative. okay? And see what happened to the field in the last 20 years. Okay, what is number 5? The oldest one. Microsoft. Totally. And Microsoft, of course, they build the operating system for PCs, and they have been ruled a monopoly, okay? But they make their money the old-fashioned way. They write software, and they get a license for the software. And what they have is an open system. Open means anybody can build PCs, put the operating system on it, and anybody can build software on top of the operating system, and you don't have to pay Windows whenever you make money on your Windows software. Amazing! But that's what we were used to. Things have changed, right? Number 4, I want to put up Amazon. Amazon is an online store. It is still kind of old-fashioned, but it's just the online version of what's out there. What is amazing here is that in the last 10, 15 years, they have, if you look at their market size, they are bigger than all the stores that we are familiar with put together. Okay? They really dominate this space. And you can buy anything, and everybody is selling through this storefront. And you can pretty much get anything there except for the things that they don't want to carry. What do they not carry? They don't carry Google Nest products. Okay? So you can see this idea that there is some kind of control over what they can do. It's their store, after all. I think the next up I want to talk about is Google search. So they of course, everybody knows Google, and they index the world, and they serve it to people. It's a really great service. But because they know what you are searching for, they're really good at putting out the ads. All right? And they make a lot of money serving these ads. It is an open system. It indexes the whole world. All right? But you can also pay them to put your product or your idea on the very top of that search page. Okay? They make money that way, but it is not. But we believe that they identify the paid ads as sponsored content. Okay? Believe that. Now, what is number 2? The fact that they are actually making money on the platform. Okay? They are not making money on the platform, but these guys are. But this is conventional, and this is it's advertising. The next up, I want to talk about the Apple. Okay? They put out this iPhone, and one product, and it sells all around the world. They're the kind of the first one to put a really smartphone out there, and they benefited from it, and that's all good. But if you want, and anybody can write software, by the way, on top of this iPhone platform, but they take a cut on the revenues. How much? 30%. 30% of all the money made on this platform belongs to Apple. I mean, imagine Microsoft saying that in the good old days. We kind of got used to it, but this is what we say. This is a closed system. And who's number 1? Of course, it's Facebook. Why is this different? Facebook is different because it is a free service, but, and they offer people a chance to share with each other. And in order for you to use the service, you have to gift your data to Facebook. You have to sign a EULA saying that they own your data. They can serve your ads based on your profile. They can also sell this data, okay? And this is the first time, this Facebook is not just closed. It obviously makes a lot of money. It also is a huge invasion of privacy in a sense. But, you don't have to use Facebook, but the truth is that 2 billion people are using Facebook. And considering that Facebook is not in China, which is another billion people, there are not a lot of people that are not on Facebook. Okay, it's hard for them to double again, for example. And of course, and of course they make a lot of money on ads. Between Google and Facebook, they make over 60% of the digital marketing revenues. But their impact is not just on advertising. If you look at what happened to journalism, the newspaper ad revenues went down from the 50 billion in 2006 to 16 billion in 2016. All right? So they're the ones who make all the content. People want to hear all this content, but at the same time, they are not the ones making the ad revenues. And now we have a problem with our industry, in a sense, across many sectors. And as a result, last year, like Wall Street Journal, New York Times, LA Times, they said, can we band together and we can do something about working with Google and Facebook in a different way. So this is like what has been happening. And I say that these are the 5 kingdoms. And now the question is, we all know that companies come and go, okay? So we know that these guys eat the internet. And so the question is, who's going to eat them? Okay? So who will eat these eaters? And of course, you know my answer. All right? I already told you. Whoever wins the virtual assistant war is going to eat this internet. Why? What does a virtual assistant do? What does the virtual assistant do? The virtual assistant says, I'm going to give you a uniform interface to all the things that you have in a very convenient way. It's a language-based interface or voice-based interface. Give me all your accounts, and I know who you are, and I would just let them access all these. You don't have to open one app after the other, okay? Now they have all your personal information. And with this personal information, they can do so much better than anybody else. You know, I would expect my ticket to Colorado to be bought, okay, even before I start thinking about planning the trip. And they can be your search engine, they can be your buyer, they hold all your personal information, and in a sense, they will become the new intermediary of all the digital resources because it is highly personalized and highly convenient and uniform, and it has a uniform interface. You know, in the past, we think we have this term, right? There is an app for it, okay? In the future, there's one app for it, okay? For anything that you would like to do because it's so much more convenient. So what do? And who is going to win? And it is very likely, if you look at the trend of the last 20 years, there is very likely that there will be one company that wins it all, or maybe there are 2. So it's a monopoly or an oligopoly. So there are a lot of societal concerns. I mean, from the consumer's point of view, you know, I really hate to see how we are not paying enough respect to privacy. And from the consumer's point of view, it's like, what if you don't want to use Facebook for sharing? What choices do you have that is convenient, you know? And from the industry point of view, we are looking at a monopoly that is very wide-ranging in power, in the services and, you know, that they can provide because they you know, once you have the intermediary, they could bias what you see in the internet and what services that are made convenient for you. So for example, you know that Amazon is not going to help you buy from Best Buy, and Google is not going to give you results from a different search engine. So the question here is, what happens if there is a monopoly or an oligopoly that is so powerful? What happens to open competition? And without that, what happens to innovation? And if that's what happens to the industry, the consumers will have less choice and less products in a sense. So what can we do? I mean, these are big efforts that all these people are leading. You know, Amazon has like 1,000 employees working on Alexa alone, right? And I think that there is really one viable alternative only, and that is open systems. And I think if you look at the recent 20 years of history, there are some successes. Remember when the AOL, when we first got the internet, the AOL wants to deliver you a walled garden. We said, we don't want this. I want a browser that I can search and I can find anything that I want. Okay, so that's what happened to the internet last time. But virtual assistant is a heavy technology. Okay, it's so convenient if you can use natural language. And if you look at the heavier technology development, I would say that if you look at the work on operating systems, which is obviously really hard technology, we really have Unix to thank for the fact that we now have iOS and Android. If Bell Labs didn't start this effort on Unix, and then it went to Berkeley for the BSD, and then of course Linux. If we didn't have this effort, what would have happened to our mobile devices? We'd probably still be using Windows, okay? And you don't have the competition to make things better. And then we can also turn to another thing that is out there that is really cool. It is one-of-a-kind database, the Wikipedia database. It is an open database. Everybody could contributes to it, and everybody can take advantage of it. And it is not something that Google could build on their own. All right. So here are some examples, and I think this is the reason why we need to have an open source virtual system, and we better start building it now. If you look at it from the company's perspective, whether they want to be a virtual assistant or not, they still want to create a natural language interface between whatever product they put out and what the consumers see. Where are they going to do all this natural language processing and so forth? Okay, it is really expensive for each individual company to try to create that kind of technology. So the only way is that we band together, put out open source software out there, and hopefully, there are a lot more competition, and you will have a lot of different products that have very nice natural language interface, and so that's the idea. So we started this project about 2 years ago, okay? And we call this we built an open source virtual assistant. We call it Almond. And first off, it is an open source virtual assistant. We want to put the technology out there for everybody to use. And so the basic idea is that you have all the interfaces to all your devices, and you have a natural language interface. And this is all open source. And what it means is that anybody can build on top of it, and they provide different collections of products. And if you take the code we have today, you can run it on your own devices. You don't have to give the credentials of your accounts to anybody, to any third party. You can own them all. And if you have it on your own devices, you don't have to hide. You can give it everything. I'm sure that not everybody here doesn't give Facebook everything that you own, but here you can actually put all your devices together. Put all the information together. Today, all our data are on all the different silos. Wouldn't it be nice for us to be able to take a uniform interface and access them all right? You have fitness data. It wouldn't be nice to say Fitbit data and Nike band data and whatever. I don't really care what device it is, but it is my data, and I want to use the same words to access them all. Right? So that's the idea behind the Almond project. So the Almond project has 4 concepts. This is the first one, which means that it is something that you can run on your own devices for privacy. The key idea is the second concept I want to describe, and that is end-user programming. Okay, so today, if you take a virtual assistant, you can turn on the lights, you can close the garage door. It's like, I can do that myself, right? But I want a real virtual assistant. Imagine I want to get into investing, and I said, oh, but I want to buy a lower price. And it's like, okay, I'm going to say to myself, when the price of the Apple stock goes below some number, and if I have still money in my checking account or in my bank, I'm just going to buy some. So I want to be reminded. So this is something you may want to say to yourself, but wouldn't it be nice if you have a virtual assistant to do that for you? Okay, so that's an example of something that we want people to be able to say. So why do we call this end-user programming? Let's take a look. So this is an example that is not just a simple command. It is actually a continuous event-driven program because you have to watch for this event to happen. It actually has multiple function calls. Okay? It is connecting your different accounts together. You have parameter passing from one function to another. And you can also put predicates on these data, on these values. So in the sense, you are writing a program. This is only an example of something you can write. There are infinitely many things that you can put together that fits your own personal need. The concept here is that I don't want somebody to write this app. Can I write an app that helps you to do this? Yes, there's probably one out there. But my point here is that if we do this end-user programming right, anybody can just use natural language. Anybody can program and get something, an event-driven program done for them without actually asking or begging anybody to write this piece of code for them. So that's the idea behind end-user programming. And how do you do this? The key technology is semantic parsing. Okay? So the concept here is that if you take something like this, you want to directly generate code from it. Yes?
Basically, you're assuming that the layperson, the typical person from the 7 billion people on Earth can write a sentence like that. I think that assumption needs to be discussed.
Well, if I can get 1 million people doing that, I'll be very happy.
Okay.
No, I have picked a harder example because I'm talking to a lot of people if I want to use a cheesy example, you say that's not programming yet. Okay, so let's see. I will actually give you some simpler examples for real. All right. So, what code would you like to generate? What programming language would you like to use for it to generate code to? C, C++, Java, JavaScript. All right. That's a long way to implementing this. And what we have come up with is our own language. It's a virtual assistant language. And we call this ThinkTalk. And as you can see here, this is an example of the code that you can generate from the sentence. They actually matches in semantics, roughly. All right? So when something happens, what happens? This is an API call. This is the kind of thing that is in the virtual assistant repository of skills. Okay? So this is a skill. And there is a predicate here. And then, so when something, get something, and then do something. And this is the first construct, and this is the primary construct in our ThinkTalk program. And it is very, very simple, but it is also very powerful because now it is leveraging all these APIs that have been out there, and you can put something together. You may think this is hard, but it is actually much, if you think about it, you're writing only 3 lines of code and getting an extremely large amount of work done for you. And that's the power of virtual assistant. This is why I'm so excited about the concept of virtual assistant. And this technology is semantic parsing. It is hard, and I'm going to get into details of that a little bit more. So what can you say with this program, with this language? So we have this ThinkTalk program. It's got a very simple construct. The when something, get something, do something, basically. So the power of this language is in the functions. Okay, what can you put together? And all those functions go into this repository. And we call this repository Thinkpedia. Okay? It's a little bit like Wikipedia, but it has all the APIs to all the digital things, the IoTs, the services, what have you. Alexa today, I've heard 2 numbers, but at least 25,000 APIs today. They open it up and everybody puts it in there. But those are Alexa's proprietary platform. It is not open to anybody to use. Okay, you can stick it up there, and Alexa can choose to do whichever they want. They can put limitations on what Google can do and what their competitors can do. It is their system. Of course, Google has its own. You know, they have the Google Assistant, and they also want people to put their platform, their APIs in there. You know, Uber or pizza and what have you. Anybody who wants to sell anything would want to put it on the platform. Why should there be so many proprietary platforms? How can we actually have, it's like Wikipedia, can we put up the world's repository? It's a little bit like, you know, you can go to any websites that are public. Why are we putting all the website URLs and give it to one company and let them do whatever they please? So this is really important that we have an open repository. We make it open. Anybody can put things in there. It is open, crowdsourced, and anybody can use it to do whatever they wish. And then so that's the component that complements this the language. Between these 2 things, you can write many, many sentences that can generate many, many programs. And the problem is this part, which I just introduced. You go to natural language, you go through semantic parser, and it actually generates constructs and functions and put them together. Technically, what is hard is, you know, how do you come up with the right language? All right, something that is useful and something that is synthesizable from the natural language. Secondly, if I want to do this kind of thing, what is the representation of Thinkpedia? It is not. It is what we put in here in our Thinkpedia has a lot more information than what the Alexa platform has. And the whole concept here is that if we, as researchers, start looking ahead, looking at things that we want to do in the future, start putting it into the representation, then we can build for the future. And I'm a big believer that we have to get the APIs right, get the representations right. If we get the representations right, everything can improve. This parser can improve and so forth. Everything can improve. But if you don't get the representation, then you will have to redo everything again. So this is why the research here includes languages, data representation, as well as machine learning for the semantic parser. And you have to do it iteratively. Okay, I can't do one without the other, and that's what we have been up to in the last 2 years. So now you have a virtual assistant that manages my stuff, and the idea is that you can have your virtual assistant managing your stuff, and we can let these virtual assistants talk together. And the coolest thing is now I can share information. All right? Anything that I can do that the virtual assistant can do for me, I can do for you too, only if I give you the approval. Now I have a very flexible way of sharing precisely the bit of information I want to share with you. Suppose I have an accountant, and I said, okay, please manage all my expenses. And they said, can I have your banking account? So I can look at your data. And I say, what? You can now move my money into your account? That's crazy. However, just talk to my virtual assistant. My virtual assistant can take the bank statement, give the part that I want to give to you, because now I can program it. So that's the basic idea behind this, is that once you have a smart agent doing things for you, it's amazing what it can do. And it is completely personalized. And what we are looking for is that this is a way for us to have distributed communication protocol. I can run my virtual assistants using different devices. I may sit with different vendors, service providers, and now I can share according to my desires. So those are the 4 ideas. It's open source, so you can have a choice. Not everybody wants to run it on their own devices. Not everybody wants to be Hillary Clinton, right? She runs her email server at home. You can if you want to, but you can go and work with, put your data in Yahoo and Google and whatever. But at least they will be competing for your data as opposed to all or nothing, right? And the end user programming is something really new. I felt like we know the power of programming. The computer science people know the power of programming, but the individuals have to depend on the developers. If we can get this technology to the end users, however million people we can, it is a good thing. We want the Thinkpedia is how we can get a new and open internet for the future, where there will be a natural language interface. And finally, sharing really needs to be improved. Today, sharing is so basic, and we have very, very poor tools for people. And as I said, we worked on it for 2 years. The first year, we built the first prototype, and we tried to train it with sentences, and it just doesn't work. We changed everything from the language to Thinkpedia, and now we've got something that actually seems pretty reasonable. And that's why we felt like we are ready to make this platform available and make it open for research. Okay, I'm not going to the end user straight away, but there is a lot of room. I mean, there are companies who may want to build on top of it for selected function, but it is technology in the making. So that's what Almond is. And before I start talking about the technology, I want to talk about what it means for the individuals. You were mentioning, can people really program this? So let's take a look. So here is an example of a day in the life with Almond. All right, 7 a.m., we need to get coffee. I have a habit, right? And I say, okay, I want an Americano from Starbucks, but only if I got up early enough. Otherwise, I'm too late. So I can just say that, right? Then you say, oh, there's too much social media out there. I want to be able to say, if there's a tweet that gets more than 100 likes, notify me. Or, oh, this happens to me all the time. You always run out of paper when you need to print something, it seems, but your IoT printer knows. Why don't you order more paper automatically? I can do search today, you can get alerts, but I'm only interested if there are home games, the women basketball home games at Stanford, okay? I want to be able to customize the search that Google may not let me do, okay? Here's a good one. You know Uber, you have to call when you can, and they say, okay, just pick me up 20 minutes after my last meeting of the day. Your virtual assistant knows your schedule, and you just have to say this. And finally, if you turn in early, you just say, okay, if I turn on the lights in the bedroom before 10, play me a movie, okay? I mean, this is just an example, right, of things that you may be doing today, but in the future, you wouldn't even think of opening one app after the other. Okay, you establish some habits, you say what you want. You don't have to have Google guess for you. Okay? So this is an example of something, for everybody. But nobody is just a common person. Everybody has their special needs, has their individual needs. Let's look at an example of an asthma patient. Okay? And it's a chronic condition, and they have to manage it. And so, for example, they may have an IoT device that they use, an inhaler, and you want to say, I want to log where I am whenever I use my inhaler. This information is really useful, but very tedious to collect if you don't automate it. And this information can be shared. That's important. They may have, Bob here may have an emergency, and you say, let my father know that I'm at the hospital, okay? There are all kinds of functions that Google will do for you when you are at certain locations. But you don't want Google to guess. There is a reason if I'm in the hospital, I want to inform my dad, okay? It is so much better if that I can tell you what I want instead of you just guessing what I want, right? And the information can be shared. As long as you have the information, your virtual assistant can share it with you. So here is an example. The doctor says that, look, I need to monitor your use of the flow meter, and if if it's below certain thresholds, I need to be notified. All these things, they can say it. And then, for example, an individual has special allergies for a particular kind of pollen, and now you can specialize this, and you say, okay, when this kind of pollen is high, then remind me not to run. Okay. So these are all examples for a particular person with a need. How do we serve this person today? Is there an asthma app out there? Actually, there are, okay? But how good are they is a different question. And how flexible it is, does it work with all the doctors? Does it work with all the IoTs? That's all different. But if we build the system in a totally different way, and you say that the user has access to all these things, they say what they want, and these primitives are executed or implemented automatically based on what the individuals can do, we'll just open up the space in a totally different way. Okay? It is not a matter of who is doing the, who will code this up for you. And the truth of the matter is that today, what software get built? It's all the monetizable ones. And how are they building it? All the rules of engagement for Facebook are done for the sake of making this product as viral as possible. And you may say that that is what people, that means that they serve the most people, but that is because it is a one-size-fits-all piece of software. And you and I know that that's not what programmability means. I want to do different things. I don't want to just share with my friends up front. Yes?
So how many things, such as inhalers, have sensors and features in it today?
It's all coming.
Coming, okay.
They're all coming. I want to build for the future.
Got it, okay.
Right? You have to. They exist, okay? 25,000 skills already, remember? All right? So let's talk about the stuff that is here. So let's talk about the technical side. I'm just going to talk about, the 4 ideas. I'm just going to tell you a little bit of each one of them. We built this, we now have a crowdsourcing pedia, and we have about 40-ish, 170 devices, 170 functions, and so forth. And what is in there? This is all the kinds of things that my students care about. Facebook, Twitter, LinkedIn, Messenger, email, Box, Dropbox, eBay, LinkedIn, and PhD Comics. It's really important for them. All right. So there are lots of things already out there. So what you need to do is to put the APIs into this repository, and it will be used. And if you look at a device like Twitter, Twitter has many open APIs, and they kind of fall into three categories. The whens, it's like you can monitor certain things like tweets, you can get information, or you can do something. And here is the English version of it, and this is the code version of it. All right, you're not going to guess what this code looks like. It is entered by the person familiar with Twitter, and these are the things that you care about, and this is the correspondence. And everything has parameters. Parameters are part of the reasons why this is actually hard. Okay, it's not just a matter of matching the function, but I have to pass things around in order to create a program. So this was crowdsourced from the students, and out of these devices, this is a cheat sheet of all the little things, all the different things that you can do. There are the reds, that are the whens, and then the yellow, or is the green, it's the gets, and then do's are the actions. And you can see that there's just a whole lot of things, and you can combine them in different ways. You can pass different parameters, and you can put filters on the different information, and you can write millions of programs just with 45 devices. All right. And this is why it is called programming, because I'm not going to give you a menu and then you can select, and it's like, okay, who wants to do that? They might as well do it yourself. So that's where the natural language comes in, is that you can just create a combination for your own self. So that's the Thinkpedia. So the language, as we mentioned, is just a simple construct: when, get, and do. Anything that is in the Thinkpedia, you can hook them up together. You can put in filters. These are the common filters. And now, because of that, you can write different sentences. So some of them are a lot easier than the stock trading thing. Okay, so when my alarm goes off, open my blinds. I think these people will say that because it is something that is really useful if you put up those blinds. Okay, get my tweets and save them to Dropbox. Okay, people want a copy of them, or you can put a time on it. And this is the one that I want my students to use. They get so much email. I want to have special priority. When I receive an email from my advisor, then send the message on SMS. Okay, this is actually true. So these are all the little things that people care about. Yes?
So this is very interesting. It sounds very much like, I don't know if you know, I'm pretty sure you know about if this, then
Yes.
that.
If this, then that.
How is it different from that?
Number one, they don't have a formal language. They have a web interface for you to hook things up. And that means that you don't have a formal language, you don't have an informal language. So the hard part is the natural language translation. And also, once you have to do this, your representation has to support all that stuff. Secondly, they are a centralized service. You want to monitor your checking account, you have to tell them your credentials. And they were surprisingly proprietary. And they said they're laying claims on the APIs that other people submit to them. They actually have over, they said like over 1 million users and many, many recipes made. So this is something that actually people want. But there's a lot of public media stuff as opposed to personal accounts. Let's just say that if you honor privacy, give them natural language, there will be a lot more usage, given that that is already being used. We are totally inspired by that, but if you look at it, they don't have, I believe they don't have gets in the, well, anyway, you can plug these things in together in using programming concepts, but we are totally inspired by that. So nobody actually, you know that in the Thinkpedia there are natural language snippets that you can put together, right? But nobody remember those snippets. And you have to let people describe things in their own words, okay? So when I say, this is more or less the kind of things you can put together, when I tweet, share the text on LinkedIn, well, this is already difficult because there is a parameter passing in here. And, but I can say it in so many different ways. Share my tweets on my LinkedIn. Whenever I tweet, post the same message on LinkedIn. I post all my tweets on LinkedIn. There are many ways that you can say this, and this is where the AI has to come in, the machine learning has to come in. You know what is the hardest thing about this project? If you want to do semantic parsing, machine learning? There's no data. I mean, I'm a systems person. We built a new system. There is no existing data. You tell an AI person, I don't have any data. How are you going to get them interested? There's nothing to do. Okay, so that is that's actually a really hard part to get started. It is hard in the future with all the ambiguity and all that stuff, but it is hard even to get started. So what do? We take the grammar of our language, we generate prototypical sentences, you know, we hook them up together. It's really clunky. And then we go to, and then we crowdsource it. We go to Amazon, AMT, Amazon Mechanical Turks, and I asked them to rephrase it. It was tricky because you have to be able to say something that they will paraphrase, and at the same time, they will actually change the sentence enough. So we actually do a lot of iterations around that. Then you come up with sentences, you can do machine learning. But these are paraphrase sentences, they are not in the wild. Then you put it into a real system, and then we also add a GUI on it, so that if you are tired of the kind of the immature machine learning algorithm, then you can say what you want with the help of GUI. Okay, you can use natural language and say Twitter, and then you have the choices. So you can kind of combine them, and then you can take the results, and then you learn it again. So I'm going to give more details tomorrow. I'm giving a talk in the class, and I'll just give you a high-level summary, and that is that given all the changes we made to ThinkTalk and Thinkpedia, we now have a learnable system. What that means is that we take the sentences and we go to the Mechanical Turk. We have a paraphrase data set. It is not the best, but it was already hard before. Okay, I couldn't get the accuracy up before. But now we can. You have to take the paraphrase data, divide them, you know, between training and testing. We actually did pretty well. I mean, so we have we report two numbers. One is the functions and one function accuracy. Do you know which functions you're talking about? When I have we only do compound of two. It's like Twitter and Dropbox. Can you identify those? And we get it's over 95%. We get them right. In terms of the program, which means all the parameters and all the filters, we get to close to 90 on the paraphrase data set. But of course, the challenge here is to go beyond, is to be able to generate sentences that the training algorithm has never seen before. And I'm going to talk about that in the class tomorrow, how we improve the extensibility. And the idea behind that is that we are using a neural network sequence to sequence, but we represent the target using grammar production rules, okay, as opposed to straight up words, which is what machine translation does. Okay. So now I want to talk about the fourth topic, which is sharing. And today, well, how many people here are on Facebook? How many people are not on Facebook? Maybe that's an easy one. This is a computer science audience. There are people not on Facebook. And what do? Okay, and the point is that whether you care about privacy or not, there is also the question of rules of engagement. I'm not interested in having friends of friends and all these things going on, but what choice do we have? So the concept here is, and then of course you have the loss of ownership, and we heard a lot about that in the last 2 days. If you don't, you can put data in the Dropbox, put photos in the Dropbox and share with your friends. It's like, it's great. I can send you a link with many characters, random letters, and they say, oh, I want to share this picture with you. It's like, what picture? Okay, what kind of usability is it? This is the 21st century, man. Now you just send me a capability? There's a big difference. What about sensitive data? We talked about the IoT, the services. And today, if I want to, as I mentioned, if I want to work with anybody, I just give them my account, password. And this is what you're doing with IFTTT. And as a matter of fact, these days, you have single sign-on. You use Gmail, Google sign-on, all kinds of accounts are linked together. I cannot even give you an account to my YouTube Red without giving you access to my email. It's like, what on earth is this? It is broken. So as we mentioned before, now if you have a smart agent that you can program, you can do a whole lot with it. So how do we do this? Again, we are using end-user programming, and it is the same deal. Okay, here's an example of a couple of sentences, and this is useful for. And the whole idea is that what I say is only executed by my virtual assistant, and the virtual assistant shares with you only what I allows it to. Okay, the granularity comes from the virtual assistant and the natural language. So here are a couple of sentences. As you can see, I get to say who it is that I want to share this information with. What can they do? Anything you can do using a ThinkTalk program, you can allow them to do. The whole when, get, do combination. And you can put limits, such as the daughter can watch TV between 6 to 8 p.m. And what it means is that you can now exercise parental control, and not the kind that Netflix puts into their system. You get to put extra constraints on the system. And you can even put in external factors, say, I'm not home. My virtual assistant can call up any of the extra Thinkpedia functions to determine things like if I am home or if it's going to rain or whatever it is that you want to talk about. It's extremely powerful. And in terms of that's the informal part. The formal part, we take ThinkTalk and we just add, what did I do here? Okay. And we just add the ability to mention who can do this, and you also add extra get predicates, such as if I'm not home. And in order to implement this, we actually we check the conformance statically, and then because there are extra predicates and filters, we can also dynamically enforce the access control. You know, computer science people have talked about access control for a gazillion years. It is so limited, but I really see the natural language and user programming as a way to open things up on what we can do on access control. Do people care about access control? We did a study. We went to Mechanical Turks, Amazon Mechanical Turks. These are not computer science people. And we picked 20 things, all the way from your computer screen, your visa, your house, your car, your accounts, your email, Netflix, Nest, and location. And we asked, would you share this information with a particular type of person, like my family, or my girlfriend, or my whatever, right? And so we asked them, and we give them a role. Okay, this is the role-based access control, and people say, not really, all the way to sure. Okay, so the blue line corresponds to just asking them if they are comfortable in sharing, and this is the percentage of the 200 people we asked whether they would be willing or comfortable to share. And that's the dark blue line. The light blue is we asked them, what if you can put constraints on them, such as the Visa card. That was surprising. I don't know if you guys share Visa cards, but apparently real people do. They suggested that to us, by the way. And what they would like to do is to put a limit on the Visa card, $20. My daughter could use it for $20. All right? So that's important. And if you put the control on top of it, it changes how much more comfortable it is. And this is for real. So people naturally need access control, but we don't know how to provide that as technologists. This one is interesting. We asked them if you would let the delivery man open the door to your house and drop off the product. And not a lot of people say yes, but how do we get people to say more? And I said, well, what if the product is over $1,000? And what if you have a security camera in the house? And then they change their minds, okay? So in other words, this is all very realistic, but every one of them has different constraints. And now the only way in order to put this together is actually natural language. So we're really changing how we share. Okay, in the past, it's either Facebook saying this is the rules of engagement about privacy. You have 3 options, or you can use capabilities. Okay, those are some of the things that we know as computer scientists, and we really have to change that for the consumers. And what we have proposed is something that works for existing data. It's your existing accounts, because the virtual assistant can do all kinds of things already today, and it will be more. There will be more. So I can do anything if there are open APIs, or Facebook says, I have data portability. If you want, I will give you all the data, okay? But what are you going to do with all the data? But now with the virtual assistant can actually read all your data using software. So if I am a Facebook user and you're not a Facebook user, I want to see those pictures. Ask my virtual assistant. My virtual assistant will give you those pictures. You don't have to join Facebook to read my Facebook pictures. So because it is executed by the virtual assistant, it discloses only the need-to-know information. It's extremely good with privacy. You have extremely good control because you can say so many different things. You don't have to wait for the service provider to write that code into the services that you are using. And it is also secure. We're going to talk about this more. And it has to be secure by getting users' confirmation, and also we have a provably correct algorithm. So in summary here is like, I think that virtual assistants will eat the internet. Well, I'm going out on a limb. How many people believe that may happen? That will happen. Woo, that's good. That's good. And I really think we need an open source platform. It's like the operating system of the old days. How can we not have an open source platform for everybody to do research and potentially, a basis for products? So we have a first attempt of that, and I really want to tell everybody about this important problem. I want as many people work on this as possible, and there is help that we need at all levels in terms of the repository as well as the technology. There is so much technology to be built. There are a lot of interesting problems. I will mention some of them tomorrow. And what I see in the future, right now, the results I got look very good, right? 90-some%. It's not really usable, okay, because they are paraphrased data, and 90-something is still not 100% and so forth, okay? But knowing, if you take Google, you take Amazon, they are definitely going to be doing this. We just want to be ahead, or at least, we do want to make the technology available to everybody at any rate. What I see in the future is that you will have a neural network, a virtual assistant that understands how the world operates. Okay, all this information, these are things built by humans. There are really not that many of them. Okay, in the grand scheme of things. You will have a neural network that understands what emails mean, what ordering pizzas mean, ordering anything, discounts, bargains, sales, whatever. They will know all these things eventually, okay? And I'm just gonna make up a word, ThingNet, that just says it's gonna be a neural network that knows how to operate the world of digital things, and it's gonna happen. And I think that hopefully the computer science people have a way of taking this technology and building things that are more useful for humans. Okay, we call this human-centered software. Okay, rather than money-centered software. and so that technology is powerful. And I think a lot of the people in the society are now thinking about what these large companies are doing to them. And I think that this is time for us to start thinking about what humans need: privacy, ownership, flexibility, whatnot. And this is going to happen. It could be the biggest nightmare, or it could be the best in terms of giving people flexibility. Well, thank you for listening.
So where is this going to run? Is it going to run on your cell phone?
You can have it run on your cell phone.
But I'm concerned with this like privacy, right? So if I talk to my phone, and my voice gets transferred to Google to get translated to.
Well, first of all,
it will understand everything I want. I talk with the virtual assistant.
Well, you have to break that down. The problem is very big. The first thing is that today in our system, the natural language is done on the server, but we don't have your data. Okay? At least you're keeping your credentials. When you say, get my balance, it is executed on your phone, and only you and the phone knows what the balance is. The fact that you have an account is something that the natural language understanding knows. Right? Then there's a second question is, what does that mean in the future? And I'm just guessing that there will be people who don't care about privacy. It's just like emails. Those that want to use Yahoo or Verizon or Google, whatever, they don't care. They like the service. And they can provide the training data in a sense. After you trained everything, can you execute against the trained model? That's something that we can potentially do in the future, and you can figure out how to obfuscate privacy and so forth. But at least the most important thing is that I don't actually have your credentials. Right? I don't know what you are. Okay, another question?
I was wondering what you talk tomorrow when that would be.
It would be more the technical side of things. I just give you the framework.
Well, you said you're speaking.
Oh, where am I speaking at?
In Clark, A103 at 12:30.
Yes, please come. 1:30. Yes.
So you said Acorn is open source, right? But then you have a Creative Commons license for it. Is that right?
Well, right now we are using, I think we are using the GNU license, GPL. We kind of leave it as the most restrictive right now, and then we're going to figure out what we need.
And the key is going to be what you allow the derivative work. So I think if somebody does something in Thinkpedia, that's a derivative work, right?
The Thinkpedia is database. I just want everybody to be able to use it. I don't want to claim anything if you use Thinkpedia.
You can say if they
But the technology, hey?
say if they can make money off of it, you can say if they have to contribute back.
Well, Thinkpedia is different. It's a database. And what I imagine,
But your license
technology is
will
different.
control that.
Yes. So give you an example. There are a lot of companies that have proprietary interfaces of their own, services and stuff. And they should have their own version, right? And then they can still do natural language and training on top of their own version. So that's an important use case for us.
Go first. Well, thank you for the talk. Just wondering, general question. Does the end user have an impact with Alvin? Making kind of the tax and talking to the client?
So,
Probably a natural language
good
could
question.
be interpreted in different ways.
Good question. Do you have a Alexa? Okay, I have an Alexa. I have so many Alexas. I can tell you personally, the only thing I use Alexa for is what's the time when I wake up in the morning. Do I have to open my eyes yet? Look at what happens to something like Alexa. You learn to speak Alexa's language. That is important to know. All right. Once I start talking and it doesn't understand me, I'm going to start learning what is something that they can understand because I have a need to get Alexa to do what I want. Yes.
Then learning about that is also probably more complicated.
It is still better than, think of it as like you learn your Unix commands. What I'm saying is that there is a transition period. At the beginning, we won't be able to just pick up any sentence. But so what did we do? We get to paraphrase and people say it differently. And we look at the template and we generate more examples looking like this. We just keep doing it. There is no end. You can have millions and millions. But right now, we're just too small in terms of the size. Eventually, you will pick them all up. And it will be pretty good. Ambiguity is a different story. You will have to start debugging, right? And then you just like anything else, if there are, it's like you will learn how to get you start differentiating more for things that you care about. The hardest problem, I think, is to tell the user what they can say or they cannot say. There are things that you want to get done that cannot be done. Okay, that part is hard. It's like, how do I want to do something, but Facebook wouldn't let you, right? But I will still try to say those things, okay? So today, the world of Wikipedia entries is still very small, and that is one of the biggest problems, which we bypass, by the way, when you use paraphrase data.
So, we are running short of time. Let's have one last question, and then if there are questions, people are around after.
I just had a point to make. It's 12:30 to talk tomorrow. That's all I want to say.
I'll announce it.
Okay.
Oh, the talk is 12:30,
12:30. Yeah.
not 1:30.
No.
Oh, that makes sense. I have a plane to catch. It's 12:30.
told you that.
Yes, exactly.
Yeah, that's right.
So there are two issues, ownership versus privacy. Facebook is a third party that owns your data, which they really totally sell it in many ways. Then privacy is usually, they said they honor privacy because they let you control what your friends see. That's what they call privacy, all right? What we are doing, if you look at our examples, the first thing we do is to make all the existing data available for sharing under your control, all right? That's the first step. What we're going to do next with the virtual assistant is that it's going to be able to keep data. Data that may be from other sources to begin with, but eventually it will become a repository of information that you can give it, all right? Then you can start storing data that is not available anywhere else, right? But for bootstrapping, you don't want to start with that problem from first. You want to start with existing data corpus. But there is really no reason why you cannot have your own data that is only kept by your virtual assistant. And I'm hoping that one day we will get there.
Thank you. Unfortunately, we do have to end this session. We want to end by presenting to our distinguished lecturer just a small token of our appreciation. And I'm going to read from the plaque presented to Monica Lam in appreciation for your Information Science and Technology Center, ISTEC, Distinguished Lecturer, Colorado State University, March 19, 2018.
Oh, okay, thank you. Thank you.
Thank you so much.
Thank you.